All right, I think it's time to get started. It's a real pleasure. It's a real pleasure to introduce today's speaker, Leidy Klotz. He comes to us from the University of Virginia, where he's the Associate Professor of Civil and Environmental Engineering and also of Architecture. Leidy started out at Lafayette College in Civil Engineering in 2000 and then actually went into the real world. And I mean the real world. He played professional soccer for a couple of years. The Pittsburgh Riverhounds, in case you're interested. And then actually worked as a engineer, project engineer and project manager for 4 years. And I guess then he decided more knowledge was in order. Yes. Ended up getting his PhD in engineering at Penn State, architectural engineering, and then spent 8 years at Princeton University, and then most recently the last couple of years at the University of Virginia. He's been working at the intersection of psychology and engineering for a long time. In fact, he's the only engineer I've met who's been doing that. And he actually found me a number of years ago when I had a research coordination network grant through the National Science Foundation. And so he's also very entrepreneurial. And we've had the pleasure of working on a couple of NSF grants since then. He's going to talk about some of this work later today. He has close to 50 papers in a variety of journals, from Nature Sustainability to Energy Efficiency, in more conventional engineering journals. And more recently, in 2016, he published a book called Sustainability Through Soccer, bringing his two careers together, which provides you with a systems perspective on sustainability through soccer examples. So all of you who like soccer, read the book. It's being used in multiple courses around the country. He's also an excellent mentor. He's had 12 PhD students, 8 of which come from groups that are underrepresented in engineering. So he's like an excellent mentor, not just to mainstream students, but to a broad range of students. He's great in procuring funding. He had gotten more than $10 million over the last 10 years from federal grants and foundations. And now I'm just going to give you Leidy to talk about his actual work.
All right, thanks, Elke. I'm glad you brought up the soccer because I couldn't fit it in here, and I like for people to know that. So the second best thing of coming to talk to you all today was I got to spend the weekend in Ocean City, and my parents were there, and then my little 3-year-old, and it's fun watching my parents interact with my 3-year-old because I think, oh wow, that's what happened to me when I was growing up. And so, like literally within 2 hours of being there, my dad and I were walking onto the beach with Ezra, our son. And my dad's showing Ezra the beach fences and explaining how the beach fences help the sand accumulate and make the dunes grow higher. And then he's going on to tell Ezra that naturally the barrier islands are along the New Jersey coast would move up and down if it weren't for man intruding on them. And Ezra's 3, by the way, so my dad's trying to explain this. Then my dad, on the same trip to the beach, he notices people catching kingfish out of the ocean, and my dad uses that as a way to kind of lead into climate change and explaining that to Ezra, how they didn't used to be catching kingfish this time of year in Ocean City. And then we get back to the house, and my mom's made Ezra a present because his birthday is at the end of this week, and it's a vest that you can wear that if you put in little power discs, and so like if a power disc has a cheetah on it, it gives you cheetah powers if you put that into your vest. So she's got like 20 different animals that he can put in and turn into different creature powers. So that's the environment that I grew up in, right? So it was impossible for me to come out of that and not appreciate the environment and everything that makes possible. As Elke said, my unique perspective, I think, on the environment, I think all of you care about the environment. My unique value I can add to an audience like this is kind of studying this engineering and behavior and how those play out for the environment. I think the most useful question I can explore with a group like this is kind of which matters more, or which holds more promise for environmental stewardship. And I've got a couple of research examples and stories to illustrate that. So as Elke said, I majored in civil engineering as an undergrad. My first foray into the real world was actually working on the Princeton Public Library. So in construction, you say, I built that, but really that means I sat in an office above Nassau Street and sent emails and faxes around. And I liked it. I liked using my civil engineering background, but it didn't seem to square with this kind of environmental motivation that I had been brought up with. I was thinking, okay, I'm building big things, but am I doing anything to address these big issues that I care about? As I was doing that, though, I started to learn more and more about the actual impacts of my industry, right? So the pie chart there is showing the different energy use by sector in the United States, and it's a pie chart that's developed by American Institute of Architects. So they frame the numbers in a way that makes themselves look good, but it's all accurate data from EIA. And so buildings are using more energy and then contributing more to CO2 emissions than cars and airplanes combined. And I still, when I tell people that, they're amazed. And so I'm thinking, oh, well, I'm actually studying an area where I can have a positive impact. The other huge thing here is that it doesn't need to be that way. The building on the slide there isn't an energy guzzling commercial building. It's actually the headquarters for Ferrera Construction Company. This is the first net zero energy commercial building in the United States, and I think it was built around 2005. It's in New Jersey. And again, it's a headquarters for a construction company, right? So not really known for doing things that are innovative or don't help their bottom line. And you start to see these examples all over when you look into it, that it's possible to do much better in the building and infrastructure industry, and and yet we're not doing so, and there's not necessarily economic barriers. So this was my realization here, is that wow, there's a lot going on that isn't what I was being taught in my engineering classes or what I was learning about through engineering calculations. So I didn't switch fields, but I did go back to graduate school. I did my PhD in architectural engineering, but while I was doing that, probably more importantly, I was reading a ton of books on the side, trying to learn about things that they don't teach us engineers. So I like to joke that people ask, what area of psychology are you in? And I say I have a BS in pop psychology. And at the same time, they were really useful books. And when you're an academic, you can kind of tell the conjectures from the rigorous research evidence in the books. All of them were super influential, but Nudge in particular, which is basically taking this idea of how do we apply this behavioral science or these behavioral insights and actually use them to make change in policy or in the real world. I mean, that really squared well with my engineering mindset, right? Because engineering is taking science and creatively applying it to try to make things better. Nudge was doing that same thing. I knew that engineers weren't thinking about this. Like Elke said, I'm the only one that she knows. I think there's a lot of engineers who think about psychology, but not from this direction. And at the same time, how could you expect behavioral scientists to understand the nuances of engineering decisions? So there seemed to be a tremendous opportunity here. And this is another way of illustrating it. So this graph we often use this in engineering to make ourselves feel really good, right? Because it shows that as the project time extends, the level of influence that you have decreases and the cost to make changes increases. And so who's up here? This is engineers and designers get to make these super influential, less expensive decisions. So that's something we use in engineering, but it applies to all types of decisions, right? It's kind of common sense. And yet a lot of these behavioral interventions are happening way down here, right? So I'll use Richard Thaler, who recently won a Nobel Prize in part for his work on Nudge. One of his favorite interventions is the Urinal Fly. And so this works in the men like me or Neanderthals bias to help you avoid overspray and ruining the waterless urinals. It's actually not a trivial intervention. It makes waterless urinals last longer, and waterless urinals cut down on the amount of water that's used to convey waste, which cuts down on the sewage treatment costs and things like that. But it's a very downstream intervention, right? Literally, it's the user interacting with the toilet. Architects and owners determine whether there's going to be a waterless urinal in the first place. Engineers determine the whole kind of water distribution system. Collectively as a society, we determine who's going to have water and things like that. So it's definitely a downstream intervention. So I was thinking about this. One of the things that that stuck with me as I'm reading these pop psychology books. I'm thinking, okay, what things could be transferred over into upstream decision making? So anchoring is our tendency to rely too heavily on one piece of information when making decisions. And this is not my anchoring study, but it's the one that best parallels the study that we ended up doing. So there's two groups of participants here. One group, the first question they get asked is, did Mahatma Gandhi live beyond age 140? The other group gets asked if he lived beyond age 9. And then they're asked, okay, well, how old was Mahatma Gandhi when he died? And theoretically, that shouldn't change the answer that people give, right? It's an irrelevant piece of information in the first question. Plus, it's clearly wrong, right? I don't think anybody thinks that Mahatma Gandhi lived to 140 or to age 9. But it influences the answer that people give. And I saw a parallel there. One of the first studies we did was with LEED, which is the rating system for green buildings, and they're basically setting unintended anchors for energy performance goals. And this was an earlier iteration of LEED. So they would essentially give you all the credits for achieving 30% better energy performance than a regular building, which, as we saw from the construction company in New Jersey, it's possible to do 100% better energy performance than a regular building. So they're inadvertently setting this anchor. The study we did gave these 4 questions, which you don't really need to be able to read because they were just anchors, and they were the equivalent of the how old was Mahatma Gandhi, or did Mahatma Gandhi live past 140 questions. They're just setting the anchor. So we set a 30% anchor with one group of participants, a 90 anchor with another group, and no anchor with a third group. And as expected, if you read the anchoring literature, or as not expected if you think that engineers are making decisions in a kind of systematic, rigorous, just based on engineering calculations way, this totally changed the goals, the energy performance goals that engineers set. And for all these studies, our basic method is to give kind of a hypothetical building, so it's not a real project they're working on, but it is real engineers. So we test all these things with students and then with real engineers. And so like the population from this was people who were LEED certified professionals or LEED accredited professionals, so real experts. And you see that by changing the anchor, you're increasing the energy performance. So it's a really low cost intervention. LEED cares about making more sustainable buildings. It's really easy for them to take that anchor out. Actually, we had a conference call with the energy committee for LEED, and they were super excited to hear of that information because that's an easy change to make. And then they, I don't know if they changed it because of our research, but it's not like that anymore in the LEED rating system. So it's a pretty powerful thing. This is one of the first studies. I did this with 4 undergraduate students. It was great because I started to get some of that funding, and funding in engineering really helps people not ask questions about why are you studying psychology. And so it gave me cover to keep exploring the things that I wanted to explore, and it also supported some of the students that Elke mentioned, which was a big deal. Most importantly, it gave me kind of street cred when I tried to contact people like Elke and said, okay, here's what I've been doing, like how could we do this better? Similar to the anchoring in my reading, I think it's a requirement in the pop psychology books to talk about defaults because it's a really powerful intervention. The chart up there on the top shows about default organ donation default rates in countries where, like the US, you have to check a box that says, yes, I want to donate my organs. The countries that have the much higher donation rates, you don't have to check the box. So it's another super simple intervention that has a huge impact. So I said, I think in our conversation, something like, hey, defaults seem promising. You know, these rating systems are setting defaults. And then Eric, who's Elke's husband and collaborator, said something polite like, actually, there's 4 channels through which defaults work. Which is really important, right? Because defaults are working partly because of cognitive effort, for example, right? It's not necessarily physical effort to check the box, but it's cognitive effort to, oh, now I have to think about this instead of just going with what's already filled out. But they also work a little bit through implied endorsement, right? So if there's something pre-checked for you, you might assume that, oh, somebody smart has thought about this and thought that that's the best decision for us to make, and therefore, since I haven't thought about it very much, I'm just going to go with what the implied endorsement is. And that nuance is really important when you're trying to have these interventions. And I use it as an example because it shows the need to kind of collaborate in person and not just through the pop psychology books, because I think with the collaboration with Elke and Eric, we've been able to get into a lot more effective interventions. Another example, and this is kind of the last one on the choice architecture, is an intervention. We've been studying Envision, which is basically LEED for mega projects. It's a rating system for infrastructure, similar to LEED, 60 credits in 5 different categories. All the things that we care about are covered there. One of the first things we did was just study whether endowing people with points changed their level of achievement. So very similar study to the anchoring study in that we said, okay, here's your simulated project, and then asked them how many points would you try to achieve on this simulated project. The only change was up here on the scale, right? So instead of this is how it's currently framed, you start with 0 points, and then you get up to 15 points if you do restorative, or 12 points if you do conserving. All we did was keep the scoring exactly the same. We just said you get 12 points if you do conserving, and you get 7 less than 12 points if you do superior, enhanced, improved, and so on. So this works on loss aversion, where it's twice as disappointing, roughly twice as disappointing to lose something it is to gain something of the exact same value. Super simple intervention, right? You're changing numbers on a piece of paper. Simply changing whether the designers gained or lost points led to a 29% increase in their sustainability goals. So again, as you would expect based on the literature, but counterintuitive for engineers, and again, done on professionals and students. Not Princeton students, but still, some of the students were pretty smart in these classes. We found similar, kind of sometimes even additive gains with other interventions. We've tried role model projects, so showing people, okay, here's a project that's done a really good job on what you're trying to do. And status quos, so implying that, okay, the status quo is something really advanced versus something that's kind of more conservative. And here's my attempt at a policy implication here. So if you scaled this to all US infrastructure, which I realize is a big leap, but 29% better just on the carbon dioxide alone, and this is just the kind of embodied energy in the infrastructure, not all the energy for the cars driving around on it. 29% better is on the order of 100 times Cash for Clunkers program, right? We spent, what was it? $3 billion on Cash for Clunkers, which I think was great. I mean, all evidence is that's a really effective policy intervention. But we could save 3 gigatons of carbon by applying these kind of little tweaks in an infrastructure system, which would not cost $3 billion. Now, I know the devil's in the details there, right? How do you get everybody using Envision? How do you scale this up to where it applies to every infrastructure project? But it shows the potential. And there's also some conservative things here, right? So I'm reducing CO2 emissions is just one of those 60 credits in Envision. And we'd get 29% better improvement across all 60 credits, things like quality of life, human resources, all of these things that we care about. So there's, I'm kind of overplaying it on one side and underplaying it on the other side. There's big potential here. That's the point, okay? And big potential with very low cost. And the last thing on this kind of piece of the presentation is that we're barely scratching the surface here, right? So we're looking at like one of the most fundamental biases, loss aversion, right? In one type of design, infrastructure. And so there's huge potential to extend the same approach to other behavioral insights. We've got a paper that we put in Nature Sustainability recently that talks about some of the most promising behavioral insights as they relate to sustainability. And also extending this to other types of design, right? I think about civil engineering type of design naturally. That's what my background's in. I don't understand small things and how their little electrons are moving around and things like that. But there's an opportunity to apply these things to all different types of engineering design, architectural design. So we're just scratching the surface, and there's a lot of opportunity. All right, so the insight here, right, if we go back to our original engineering or behavior, well, many engineers are seeming to behave like humans based on the evidence that we're collecting. All right, so second part of the presentation. Let's keep exploring this engineering or human behavior. So we visited San Francisco last summer. The Embarcadero was the first place on my wife's to-do list. We walked around there. Ezra was 2 at the time. He got a balloon monkey, and then he walked over to show it to the harbor seals. If you go to San Francisco now, I mean, you end up going to the Embarcadero. But if you look at the history of what it used to be, and one of my former grad students kind of turned me on to this, but so this was the Embarcadero up until 1989. There's a 2-level freeway going over this, going right in front of this ferry building. So basically none of this, which is basically San Francisco's top attraction right now, none of that existed because they wanted to have a double-decker freeway going through that section. And if you look at how hard it was to get rid of the freeway, it was incredibly difficult. I mean, the planners did a ton of planning efforts. They studied social, environmental, economic costs and benefits, and recommended that it be removed. The city forced a vote, and it was like 2-1. No, don't get rid of this double-decker freeway. Even after the World Series earthquake in 1989, so this freeway got damaged. There's a freeway in Oakland that looked exactly like this freeway that collapsed and caused most of the deaths from that earthquake. And people were still resistant to getting rid of what was now a damaged freeway that looked ominously like one that had collapsed next door. And eventually it did come down, but in 1991, after this freeway came down, the mayor who had kind of pushed it through and the entire planning commission got voted out, in part for their unpopular efforts removing it. And now people, so this is called Herb Cain Boulevard. It's named after a Pulitzer Prize winning columnist for the San Francisco Chronicle. Herb Cain, right after the earthquake, said in the San Francisco Chronicle, he said, now people are talking again about removing the Embarcadero. What did he say? The only idea worse than building it in the first place, right? So he was totally against it, and now the boulevard's named after him. The point is not that people are stupid. There are a lot of engineers and planners and policymakers and elected officials who were saying, let's keep the freeway. The bigger point is that it's that this is a fundamental, or that this is something, we make decisions about infrastructure, right? This is not a decision that's made by some engineer sitting in a silo or some planner sitting in a silo or some elected official even. The residents of San Francisco is a very participatory process, and the decisions we make about infrastructure are some of our longest lasting legacy, right? And some of our longest lasting environmental legacy. I also like this example because it illustrates one of my favorite types of infrastructure project, or civil engineering type project. The principle is here too. So I don't think there's any kind of one-size-fits-all sustainability solutions for infrastructure, but all of these things are among my favorites because they have a common theme. This is Kate Orff, who's a landscape architect. She's gotten a bunch of publicity recently. She's working a lot on the Hurricane Sandy restoration, so constructed wetlands and things like that around the New York City area to protect from those storms. This was before she got famous for that. This is her stormwater design in Lexington, Kentucky, and if you see kind of the overarching principles, right? Reveal, clean, carve, connect. These are subtractive ideas, or not necessarily additive ideas, which is counterintuitive for infrastructure. The stereotypical stormwater infrastructure approach is let's go in, put some pipes and pumps, get the water out of here, get it to a treatment plant. She's saying, let's reveal the stream that's going through the middle of our city. Let's clean this space up. Let's carve through here so that it can connect to other spaces. So she's using subtractive elements to her design. Hans Modermann's designs in Denmark. This is, in New Jersey we have the jug handle, right? This is a traffic circle there, and what's missing, right? All the signals and things like that. Again, these aren't one-size-fits-all solutions. I wouldn't just kind of put this in the middle of New Jersey without warning people. But in the right context, this slows down drivers, makes people feel like makes it evident to everybody that people have equal rights to the street, and actually is a really effective design. It works by getting rid of the signals and signage. Take it down to the building scale, so you see kind of passive ventilation, right? And that works a lot of the times, or one of the reasons that that's effective, or one of the things that it enables is to get rid of the mechanical systems, right? So you're making people cool or warm or giving them comfort in a different way, and that way involves thinking about the passive airflows through the building, but also getting rid of the mechanical system. So again, subtractive design. Even going down one more scale, Anna Kikeline, she was the first woman architect in Pennsylvania, and around 1919 she invented this. It's called the K-brick. I guess she named it after her first letter of her last name. But the innovation here is the space here and here and here. Before that, bricks were pretty solid, which kind of makes sense. Why would you cut holes in something that you want to be strong? But if you make holes in it, it actually keeps the strength that you need, and these holes are better for insulating and reduce some of the material needs for bricks. So this was a really big step towards what you see as the ubiquitous building block now. That was a big improvement on the current practice. And Kikeline's fundamental insight, I mean, she got a patent for this brick, was let's take away material, right? So these designs are different, they're counterintuitive, they take away as much as they add, and I think they're cool. I think they kind of thread a really important needle for sustainability. Now, I've been thinking about that for basically my whole life, I think. I would say my whole academic career, but I also mowed grass when I was in college, and when you mow grass, you have a lot of time to think, and when I wasn't thinking about soccer, I would be thinking about why does this grass exist when I'm the only person who goes on it and my only purpose for going on it is to mow it? So those are kind of maybe the genesis of this idea. This isn't a made-up story. I mean, the real epiphany came again from Ezra. So I spend a lot of time playing with Legos. We're onto regular size Legos, but the epiphany came with Duplos. And Ezra and I are sitting there playing with Duplos. We're constructing a bridge, and we've got two columns. One column was shorter than the other column, right? And so I turned around behind me to get another block to put on top of the column so that we could span across and have a level bridge. By the time I turned around, Ezra had taken a block off of the taller column and spanned across. And now I'm not saying Ezra's a subtractive genius. He's like worse than I am at just adding things. But it was the perfect kind of illustration, and I have the Lego in my bag. I took it to Gabe Adams, who's a social psychologist friend, and I take Gabe ideas, and I took her like 5 ideas, and the first 4, she's like, oh yeah, those are interesting. Let's talk about those next meeting. And but the Lego one, she's like, oh, that's super insightful. Like, so the question is really, why don't we see subtracting as a way of improving, which I'd been thinking about that for 10 years, but was not able to articulate it in a way that could actually be studied. And Gabe brought in Ben Converse and Andy Hale, a couple other social psychologists, and they're amazing at kind of operationalizing these things into experiments. So we kind of started testing that question, why don't we see subtracting as a way of improving? This is one of our first studies, so inspired by Ezra's Legos, but this is the experimental setup. You just gave people a block of a mass of Legos. They had a stockpile too, and said, improve it. We gave it to 60 people, 59 out of 60 added. One person took away blocks. The one person who did take away blocks actually made a bigger structure, like it took up more volume, but they took away blocks to do it. So that we've done it with other structures that are kind of simplified or intentionally designed to make subtraction a viable option. So we gave them a replica of like Ezra's original bridge structure, and people still take away. We're playing around with this one now, so one of the other social psychologists we talked to is like, well, could you show that people still do this even when subtracting is objectively the best option? So the challenge here with the Stormtrooper, and this works with Stormtrooper, it works if you switch the Stormtrooper out with the Lego Batman too, but the challenge is to put this brick on top of the Lego tower and keep it from crushing the Stormtrooper. Now the solution, the subtractive solution, is just to take out that block in the corner, move this down, it's still over this guy's head, and even sturdier to hold the brick. Still, people overwhelming, not 1 in 60, but it's still more people try to add to improve this than take away. Now, I understand that, Legos, there's some kind of functional fixedness there, right? These are Legos. What do we do with Legos we build? I mean, we might ask ourselves, why do we build with Legos? But we needed to explore this in other contexts. So we've studied it with music composition, grilled cheese sandwiches. My favorite is the blocks on a computer screen, because I think that's the most kind of elegant way of doing it. So we give people, there's not a red circle on these, but we give people these two pictures and say, okay, your challenge is to make changes to the grid so that if you overlaid this on top of that, they match up. So again, you got 50-50 adding versus subtracting. One is to put the L over here. The other one is to get rid of that L. And people overwhelmingly add. So this is research in progress. I think we're trying to learn more about like what the mechanisms are behind it. Why are people behaving this way? Is it something where they're not even seeing the subtraction, which we're kind of leaning towards, or is it something where they see subtraction as a less desirable option? But just think about the implications of that for engineering our infrastructure, right? So if we're talking about like getting rid of the Embarcadero, and I know there's other biases that tie in, other very real influences, right? It's pretty hard if you're an engineering company to say, oh, we've got a great solution for you. The solution is to not hire us and to just get rid of this freeway. So I understand there's other forces there, but if there's this kind of underlying thing going on where people can't even see subtraction as a way to improve things, then we're missing out on some pretty big opportunities. Plans for future research here. I talked a little bit about mechanism, a little bit like kind of why this is happening. I think this is Ezra's city that he built at school. Like I said, he's not a subtracting genius by any means. He had to go into the other room to take blocks out. But just look how happy he is, right? So like, is efficacy something that's underlying here, right? So people kind of are motivated to show competence that they can make change in the real world. The other interesting questions about like contextual differences. So if I'm watching Ezra, one of the few times when he does what I think of as takeaway is when he's digging holes in dirt. And so maybe we're more likely to take away from environments that we don't perceive as being made by humans. That's something that we're exploring in some of the experimental research, but have no idea what the findings would be. I also think we need to look at this in individualistic versus collectivist cultures, that there's probably some interesting differences there. And I think environmentalists tend to get why subtraction is important, but I'd like to explain why I think it is too. So if you haven't read this book yet, I'm sure you'll love it. It's by Charles Mann. He wrote 1491 and 1493. He's a terrific writer. When I read this book, I was like, I can't believe this guy wrote this book, because it's totally for environmentalists. It's not for a wide audience. And he's basically talking about the wizard and the prophet are these kind of dueling approaches to having a better future, right? So it's not people who don't believe in climate or don't understand climate change versus people who do. It's people who want to make the future better and just have differing approaches to try to do it. So the wizards are people like, he uses Norman Borlaug, who did a lot of the Green Revolution. Elon Musk is a wizard, right? So we keep advancing and we will solve these problems. Prophets are kind of the limits to growth. Infinite growth on a finite planet is impossible. Bill McKibben is a prominent writer who falls more into that category. And Mann's point is that both of these groups are really well-meaning, and of course it's a continuum between wizards and prophets, but he feels like people tend to be way on one side or the other. But I think maybe the subtractive innovation could kind of thread that needle. So if you're one of the wizards, right, and you want to create to make things better, but all you do is see adding is the way to create, or adding is the way to improve, then that does kind of lead to environmental problems fundamentally. But if you could see subtracting as a way to improve and keep creating, then that would be a promising middle ground. So that's kind of how I see subtracting fitting into the big environmental questions. And I think there's a lot of opportunity to study things like that where these, so I'll leave it at that. That's where I see it fitting in. So back to our fundamental question, right? So engineering or behavior. Well, engineering is human behavior, right? So add, subtract, that's like the core engineering question. Imagine how many other engineering type questions there are like that, or opportunities there are like that. And what maybe we could find some really surprising answers there too. So a lot of you probably recognize this from the start, that engineering behavior isn't really a question, right? These are things that should be brought together. And that's the last things that I'll leave you with, is to kind of challenge you to think about that as a component of engineering, or if you're not from an engineering background, to think about, okay, how can we draw on the best of engineering to help with this? So historically, engineering, if you look at Wikipedia, it says engineering, creative application of science, right? And historically, it's been applying physical science and formal sciences, so physics, chemistry, math, logic. Even the applications of biological science are relatively recent, kind of the 1950s and after. But engineering, while we do kind of touch on some behavioral science, there's human factors. Elke teaches a class in Human Factors 2.0, which is saying we need to go beyond human factors engineering, because human factors engineering has, I don't know, the negative way of framing what human factors engineering is like kind of dealing with the nuance that is people that are influencing our engineering design, or the nuisance that is people that are influencing our engineering design, as opposed to saying, let's start with what we know about behavioral science and see if we can create engineering designs from that background. So bringing behavioral science into that toolkit that engineers apply. And again, like I said, it's not really different than what Nudge and some of these other applications of behavioral science are advocating. And I don't think it should be solely the domain of engineers, but I think engineers have a lot to bring to it. And I think that as Gabe and Ben and Andy, who are my behavioral science collaborators, and also Elke, hopefully, there's new opportunities for behavioral science here too, right? Because you get to see some new situations, new influential decisions, new upstream decisions that you might not otherwise be able to influence. All right, so I'll leave you with kind of some of the activities that are coming up in the next year. We'd love to have you join us in this idea of moving behavioral science closer into what engineers do, and vice versa. We've got our website just went live for our Convergent Behavioral Science Initiative at University of Virginia. This is something I started with a colleague at Darden, which is the School of Business there. Basically, a whole bunch of people applying behavioral science. We've got dozens of faculty from different disciplines, lots of wonderful graduate students. You see here that engineering is one of the kind of groups that we're intentionally bringing in. There's opportunities for visiting faculty, graduate school, just kind of come down, give a talk, see what's going on with that group. In the next year or so with Elke, some of the things we're working on, we're doing a panel with Nature Sustainability that talks about this intersection of behavioral science and engineering design for sustainability, of course. That's going to be in New York City in January, and we'll report what the experts find from that. And then I think one of the things I'm most excited about, we have a planning grant from the National Science Foundation for an engineering research center. So these are big awards if you get awarded. This is just a planning grant for it. But the idea for the planning grant is bringing convergent engineering and behavioral science for infrastructure. In the next year, we're going to be working on that with Elke and I. We're working with Ideas 42, which is a behavioral science consultancy in New York City, and they have a bunch of Princeton alums on their staff. So there'll be opportunities to get involved in the planning of that and kind of shaping the direction of that if you're interested. With all these things, just shoot me an email, and we'll plug you in where it makes sense. And I think the last thing that gives me hope for this kind of convergence is we've just had 10 new PhD students join our program at UVA, and they're obviously super smart. A lot of them have industry experience, and they've said, I'm going to devote the next 3 to 5 years of my life to studying this and put myself on a track to become conversant and develop expertise in this area. And that's a pretty big pretty big vote of confidence from my perspective that this is something that we need to be doing. So those students, 10 PhD students and about 5 postdocs who have decided to do that are really promising evidence for me that this is an area that's going to keep growing and continue to help with some of our environmental challenges. So I'll leave it at that. I look forward to the discussion. Thanks. I think it's so awesome for collaborators with kids, but somebody else has actually brought that up. He hasn't started playing it yet.
Okay, so serious question.
Is that the one though? Well, that is kind of serious. I mean, is it?
It is like Legos, especially
Right, yeah.
transition from Legos to Minecraft.
No, I mean, we need to be able to put it on the computer for experimental ease, because running the Lego experiment is a
Minecraft
pain.
is set up as subtractive. The idea was mining first, but then everybody builds stuff now, so it's a good
Okay,
side.
so that's 2 votes for Minecraft. Yeah.
For like construction in buildings, I'm wondering about the idea of assembly and the fact that a lot of the research in architecture department in
Yeah.
Digital fabrication has historically all been subtracted, and the new research is all additive. So I'm wondering how much the process of assembly relates to sort of what I was hearing more as like the fundamental fluidity aspect of addition and subtraction being at the core of the argument, whereas like the actual process of physically going through assembly is more linear to some extent. Has that been something like looking at the way people build things? Has that come to light because the experiments seem more fundamental, I guess?
Yeah, no, so I'm also working on a book on like subtraction. I think the experiments is one chapter, right? There's a much bigger story there, and I think, I mean, I'm trying to paraphrase. Correct me if I'm doing it not accurate to what you said, but I mean, when we're designing, it's really a series of decisions. It's not, hey, am I going to subtract or am I going to add? It's, do I do subtraction as part of my thought process? And yeah, that it's something we've thought about but haven't studied. I mean, I think there's, at least in architecture, they talk about it, right? You can talk about negative space and positive forms and negative forms, and then the assembly one's really interesting. So I talked to a woman who has a background in mechanical engineering, and she talked about the difference between like 3D printing versus CNC machines, right? So CNC, it's fundamentally about what do you take away, and the 3D printing, it's additive. So that would be really interesting to look at as kind of a form of choice architecture. I'd also like to even just talk more about what you see as I'm interested in how people are trained for it, because I think I have a sense that architecture might train people a little more for it than engineering, but I don't know.
Thanks for the talk. I was wondering, on some of the earlier work you presented around anchoring and sustainability goals, can you talk a little bit more about how, like, are these the same effects that we see on an individual level versus organizational level? Because I imagine there's a whole lot of other factors at play with, like, companies or large organizations make decisions based on their information.
Yeah, that's a great question. So, I mean, our experiments have just been an individual making a decision, which is totally, that's not the way that a decision about the energy performance of the building would get made in reality, right? I mean, you'd probably have 10 different stakeholders deciding on that goal for the building. So we narrow it down just for the sake of studying it, but it would totally be more of an organizational decision. We just haven't studied it that much. We've had it on our list. It's hard to operationalize it. Do you have theories about why it might be different, or?
Well, it resonates. I mean, I used to work in the oil and gas industry as an engineer in the sustainability department, and you totally see one company came out with like, we'll reduce our GHG emissions by 30% by 2030 or something. All of a sudden, 5 other companies will come out with the same goal.
Yeah.
So part of that might just be like investor or whatever stakeholder expectations, but it'd be interesting to see if like the same psychological forces are also at play.
Yeah, I don't know the answers, but there's Evan Pullman, I think is his name. Is that he's at Wisconsin, he specifically looks at these things in kind of organizational context. Sure.
Very interested in the idea of subtraction as it relates to land use, and particularly the conversion of natural ecosystems.
Yeah.
The built environment and the transition back from the built environment into more natural
Yeah.
Have you come across a lot of examples of people thinking about that as potentially one of the barriers that humans have to seeing a currently built environment like in New Jersey on the coastline maybe being better served as natural infrastructure?
Yeah, I would hesitate to say, I'd like to play up the role of what we're seeing with subtraction versus some other things, which would just be kind of loss aversion, status quo bias, and things like that. But regardless of my sense is it matters less what the actual phenomenon are and more that you're recognizing that it's not just a kind of rational decision-making process and trying to figure out what's actually holding people back from, our house on Ocean City that's like on an island that's supposed to move up and down the coast. What's holding people back from kind of planned retreat from places like that? So, yeah, I know that's an ambiguous answer to your question, but I like how you articulated the kind of the going back and forth and talking about it in a cyclical way. I think that's one of the reasons I'm interested in looking at it in the individualistic versus the collectivist cultures that might have more of a kind of cyclical mindset that, oh yeah, if we have added, then it's natural to be subtracting later. It's also, the coastlines, it's a question, but also kind of shrinking cities. People have talked about in places like Detroit, right, where the population is much smaller. What do you do in those kind of in-between areas?
Are there implications for your research in terms of operationalizing energy efficiency, particularly not so for residential, but at scale?
Uh-huh.
The big, I've been told by folks who've been senior vice presidents for big oil companies.
Right.
It's much harder to get capital freed up for efficiency, even if it's at the same ROI as for another application. So I was wondering if there's any light you could shed on how to make energy efficiency more appealing.
Yeah, I don't know. That's my background. I understand more of the nuances of like how those decisions are made in infrastructure and not necessarily in the oil and gas industry, but it does seem like there's a huge that like tweaking the financial mechanisms might be more important, or those types of incentives might be more important than the kind of behavioral interventions at that point, because it's a pretty, if you're not getting paid the same amount for doing efficiency investments, or if there's a different financial incentive for those than there is for improvements, or if there's different kind of reactions from stockholders, then I think that's a different question, maybe. So.
It's about comfort level.
Comfort level with the. Oh, yeah.
In that regard, to the comfort, have you found examples where the energy efficiency measure may remove something, and by removing it, you can't point to it and see it? Or like the idea of additive being the thing you can see.
Yeah.
And taking stuff away to make it better results in a void, and a void is hard to point at.
Yeah. Well, that's the efficacy part, right? It's like, okay, you did this awesome design. Well, what's your design, Forrest? It's that hole, right? You can't see it. It's that beach that doesn't have anything on it now. So yeah, that's something I've thought about a lot, and I think is a big explanation probably, especially for engineers, right? Because if you tie in, like, what's efficacy for an engineer? That means, well, I've been trained my whole life to design and build things. That's like my unique skill is to make this thing stand up in the sky and fight against nature. It's not to take things away. So, yeah.
Does any of your work look at cross-cultural or sort of international differences?
Not yet. We did we replicated some of the kind of choice architecture on Envision studies in, this is in the Middle East, but it was a very kind of similar to a Western culture where we had replicated it. But I think that's an area we definitely need to go. I'm just trying to convince one of these 10 PhD students to spend some time traveling around the world, replicating some of the Lego studies. I think there's, yeah.
Have you tried to understand why those behavioral nudges worked in your context, like with follow-up interviews with engineers?
Yeah, well, so the first one was before he started collaborating with Elke and had the good idea to put questions at the end of the surveys and ask them like, okay, what was happening here in your brain? So I don't know about the first one. I think, and then the other studies with Envision, the infrastructure rating system, we have asked them things like why, okay, or even disclosing the choice architecture, right? And saying, okay, here's what we were doing. Does that bother you? And that doesn't seem to bother them. I think we've asked them things like with the loss of, with the kind of changing the framing and endowing them with points as opposed to taking them away. We've asked them like, how did this make you feel after the fact? And I mean, all the questions we've asked about after the fact have been really aren't saying anything or aren't contributing more to our understanding. They're saying, no, this didn't make me feel any better or worse, like taking away or adding points. So I don't know if that leads us to believe that it's kind of purely psychological or not.
Any more questions? Then let's give Leidy another hand.
Oh, thanks.